Hi guys, welcome back to another one of my videos. I know it's been a few weeks, but I got busy with tests and then I went away. I'm back now, and I know it says gas laws on the title screen because I will be talking about gas laws today. Not continuing with the matter just yet because me and some classmates have a test on this very soon, and we just started this unit. So I figured I'd just make a video explaining to help us. So, let's get started. First up, we have Boyle's law. Boyle's law states the relationship between pressure and volume at constant temperature. Um, so, at constant temperature, pressure and volume are inversely proportional, which means that as pressure goes up, volume goes down, and as pressure goes down, volume goes up. That is very important to remember. This is what the graph looks like. So let's say this is the y-axis is pressure, and the x-axis is volume. As pressure goes down, volume increases, but go, as volume goes up, no wait, as you go down this way, as pressure goes down, volume increases. As volume goes down, pressure increases. So, yeah. And that's the formula. Pressure P1 times V1 equals P2 equals V2. Or pressure 1 times volume 1 equals pressure 2 times volume 2. So right now I'll do two sample questions for Boyle's law. So the first question is, a sample of oxygen gas occupies a volume of 250 milliliters at 740 torr pressure. What volume will it occupy at 800 torr pressure? So this question talks about only volume and pressure, no temperature. So that's how you know it's Boyle's law. And so first we wanna like write down our formula. It's P1 times V1 equals P2 times V2. So we start off with 250. So this is milliliters. So this is V1, and this is our P1 because that's the pressure we start off at. This is our P2. So we're looking for our V2. So over here we'll set up. That'd be 740 point time and you always want to add your units. Torr times 250 point milliliters equals our P2 is 800 point torr times V2. So now we get our calculator out and multiply 740 by 250, which is 185,000 equals 800 V2. So now we just divide both sides by 800 and if we get that should equal V2, it would equal 231.25. But since we only have three significant figures, it would be 231 milliliters. So that's the first one. And now, so the second question for Boyle's law is ammonia gas occupies a volume of 450 milliliters at a pressure of 720 millimeters per. Oh my god. Okay, ammonia gas occupies a volume of 450 milliliters at a pressure of 720 millimeters mercury. What volume will it occupy at standard atmospheric pressure? Um, so why don't you try pausing the video and see if you could solve that first, and I'll solve it in a minute. Okay, so I forgot to mention that when you're solving for standard atmospheric pressure or standard anything, standard atmospheric pressure or standard temperature, there are certain values that you have to use to sub in, since it won't give you the value. You'll have to know this, and you'll have to memorize this as well. So standard atmospheric pressure is always going to be 1 atm, 101.3 kilopascals, 760 millimeters of mercury, or 760 torrs. So yeah, now that's the setup, and I will write down the answer, which is insignificant, rounded to the significant figures, is 426 millimeters. Milliliters. I think I said millimeters on accident. So yeah, that is part 1 of the gas laws video. I will do Charles' law, Gay-Lussac's law, and combined gas laws in their own separate parts, since this took longer than I thought. Thank you for watching. I hope this helped you, and I will see you in the next one.